Hi everyone, welcome to part 2 of our lesson 4.1, and we're looking now at cube roots and perfect cubes. So we're going to skip ahead a little bit in our notes to where we left off. And we're at the top of your page there where it says perfect cube. Okay, it's I think labeled page 5 in your notes. So perfect cubes, very much like a perfect square, the word cube stands for cubing, telling us that we are talking about something which we're going to use in a multiplication 3 times. That's what cubing means. And it's a product of 3 equal factors then. So 5 cubed, okay. So in other words, a cube is an exponent 3. So there's my exponent. So cubing tells me to use this factor 5 3 times in a multiplication. And in other words, multiply 5 by itself 3 times. So multiply by 5 by itself, okay, that number, 3 times. All right, so that's going to look like this. We have 5 times 5 times 5. And so 5 times 5 is 25. Okay, and 25 times 5 is 125. And so this number that I get, the product, 125, would be called a perfect cube. Okay, because it's the result of the product of taking a number and cubing it. Great. 27 is also a perfect cube. What numbers multiplied by themselves give me 27? Okay, well, sometimes you recognize these right away. You might be more familiar with perfect squares than you are with perfect cubes, but we do want to start to recognize some of them, and the answer is 3. 3 multiplied by itself 3 times gives me 27. And you might have said, well, I know that 3 times 9 gives me 27, and 9 is a perfect square, right? 9 is 3 times 3. So there we go. 3 cubed gives me 27. 3 times 3 gives me 9. Times 3 again gives me 27. So 27, we call that a perfect cube, and 3 is the cube root. Okay, it's the factor that I use to give me that perfect cube. Oh, sorry. A cube root, just like a square root, uses a root symbol. Okay, and when we take the cube root of a number, we undo the cubing. So we get that factor back, okay, that we would have used had we been trying to get the perfect cube. So let me say that a little differently. So let's do an example. Okay, let's say we have the number 8, okay, and this is a perfect cube. So 8 is also a perfect cube. It comes from using the number 2 in a multiplication 3 times. And so how do you recognize a cube root? Well, a cube root will have a symbol that looks like this. It's got that square root symbol, except it has a 3 in the index. That little pocket of the root symbol is called the index. The number that you see in there, we refer to as the index, and there's a 3. So whenever you see a 3 in there, it's telling you to take the cube root. Okay, so let's think about, well, what number multiplied by itself 3 times would give me 8? Well, it turns out to be 2. 2 cubed gives me 8. So 2 times 2 times 2, we write it like that as well. Okay, 2 cubed will give me the number 8, so 8 is a perfect cube. And by taking the cube root of a perfect cube, we're going to get back just one of those factors. So another way to say that is that taking the cube root undoes the cubing. Okay, so our answer to the cube root of 8 is 2. Okay, because if I wanted to check, if I wanted to get back to this number again, okay, I could just simply cube it. To get back, so a good check, if you want to make sure you did it correctly, is to say, well, if I cubed it again, I put that exponent 3 back on, I should get the number that I had inside my root symbol, that perfect cube, which is 8. And that would be true. 2 times 2 is 4. 4 times 2 is 8. So we use the symbol cube rooting. Okay, it has to have that little 3 inside the index to represent the cube root. Let's do another one. Okay, what's the cube root of 1,000? Okay, again, think about what number multiplied by itself 3 times would give me 1,000. The answer turns out to be 10. And again, if you don't recognize that right away, you might think to yourself, well, I know that 100 times 10 gives me 1,000. Okay, and 100 is a perfect square. It's 10 times 10. So if I bring that other 10 down, 1,000 is equal to 10 times 10 times 10. Okay, or 10 cubed is another way to say that. So when I cube root a perfect cube, I get just one of those factors back. So I'm just going to get the number 10 as my answer. Okay, excellent. With a cube root, we don't have the option here of saying plus or minus because actually it's not true that negative 10 could not be my answer, because negative 10 times negative 10 times negative 10, 2 of those negatives will cancel each other out, but I'll still be left with one negative sign out front, and that would be negative 1,000. Okay, negative 1,000 was not the number that I had, okay, inside my root symbol. So when we're doing cube roots, our answers are just simply going to come out for now to be positives, okay, unless the number inside is a negative. Okay, so for now we're just, we do have to think about that. So we're not putting the plus or minus sign in front of the answer to a cube root. Let's do some examples here and talk about using your calculator. So on your calculator, you will have one of a couple of different buttons. So you'll either have a cubing button, and if you do, that's really handy. Okay, if you have that button, that's great. Lots of calculators don't. And so you might have an exponent button that's going to look like this. Okay, or that's going to look like this. Both of these buttons mean exponent. So if you want to cube a number, okay, on your calculator, you're simply going to hit the exponent button and you're going to type in a 3 after that number, or after the exponent key, so that you're going to cube it. So 6 cubed on your calculator would look like this. You would say 6. Okay, and then you'd hit either your exponent button, okay, or the y to the x button, whatever you've got there, and you're going to put in a 3, and that tells your calculator to make 3 the exponent, okay, and your answer should come out to, well, 6 times 6, okay, it's 36, and 36 times 3 is 216. So by the way, if you're ever in doubt, you can always just do that in your calculator. This is the same as 6 times 6 times 6. So you always have that option as well. Okay, finding the cube root on your calculator, you will have a button that looks like, most people don't have a cube root button, but if you do, that's great. Okay, that's just like your square root button, except you'll see a little 3 in the index. And so if you have that button, that you can immediately use that to take the cube root of any number. But most people will have a button that looks like this. Okay, and it's an x to the y. Okay, it looks like that. And this button can be used for any root. So it allows you to put any number in here for x. In this case, we're going to be putting in a 3. Okay, but you could take the 4th root or the 5th root or the 6th root or the square root using that button. It's a generic button that can be used for anything. How you put it into your calculator is important. So let's do an example. If I want to take the cube root of 729, okay, I'd like you actually to have your calculator handy and try this with me right now, just to make sure that you know how to use it in your calculator. So you might have to put what this is called, well, our perfect cube, okay, or this is also called the radicand. But let's put that big number inside the root symbol. Put that into your calculator first. You could try it this way. Okay, and then you're going to, so you're saying, I want to take the cube root of this number, and then so you use that root button on your calculator, and then you're going to put in a 3 so that you're telling your calculator to take the cube root of that. Okay, so you might have to put the cube root, the index in last. Okay, or okay, you might have to do the opposite. You might have to first put in the 3. Okay, and then hit your root button. And if you do it that way, okay, you're just gonna have to try it for yourself. Okay, if your calculator will just give you an error or the wrong answer, so we're gonna check it right now. Okay, if I put in a 3 and then I put that root button in, it's telling me to take the cube root of what number? Well, I'm gonna put the big number y, okay, in after. So try those out for yourselves. Okay, and the answer that you should be getting on your calculator is going to be 9. Okay, because 9 times 9 is 81. 81 times 9 gives me 729. So try it for yourself. You just need to know how to operate your own calculator. Okay, but it will. Most calculators have a button like that, a root button on it, and so one of these two orders will work for your calculator, and you just need to know whether you have to put the exponent in at the root in at the end or the beginning. Okay. Okay, let's do some other examples here. So let's express our answer as an integer or fraction. Fraction, just if we're given a fraction, we may have to leave our answer as a fraction. So let's go ahead and get started. So 8 cubed. Well, 8 cubed is equal to 8 times 8 times 8. Okay, 8 times 8 is 64. And 64 times 8 is 512, but I could have also used my calculator and said 8 exponent 3 or 8 cubed, and that gives me 512. Let's do the next one. I have negative 8 cubed. If you have a negative inside the brackets, okay, that tells you to use negative 8, okay, whatever number is inside your brackets, in a multiplication 3 times. So every time you're saying negative 8 times negative 8 times negative 8 again. So my answer is going to come out to 512 again, except let's look at the sign. We have one negative times another negative, which will give us a positive, and a positive times a negative will give us a negative as our product. So anytime you're cubing a negative number, your answer is always going to be negative, okay, because 2 of those negative signs will cancel, and you're left with still one negative sign out front. Okay, so when you have brackets, you cube what's in the brackets, and our answer comes out to be negative. Okay, let's do the next one. Negative 8 cubed, but no brackets. So no brackets, that negative sign stays out front because we're not actually cubing negative 8. We're only cubing the 8. So you're only cubing directly whatever the exponent is attached to directly. So this is 8 times 8 times 8. So my answer comes out to be negative 512 again. Okay, but for a different reason, because that negative sign needs to be left out front. Let's do a fraction. So we have 3 over 4 cubed. Okay, again, there's 2 ways you can think of this. This is equal to 3 cubed over 4 cubed. So we're going to get into exponent laws a little bit later. But if I have a exponent 3 outside the brackets, I'm actually able to apply that to everything that's inside the brackets. Okay, so that's one way of thinking about this. This is the same as 3 cubed over 4 cubed. Another way of thinking of this is it's the same as 3 over 4 multiplied by itself 3 times. Okay, and I have fractions, multiplying fractions. Remember what we said, we multiply the tops. Okay, and we multiply the bottoms. So on the top I have 3 times 3 times 3. Okay, well 3 times 3 is 9. 9 times 3 is 27. And on the bottom I have 4 times 4, which is 16. And 16 times 4, which is 64. Okay, and on your calculator you could have also said 3 cubed equals 27. 4 cubed equals 64. Okay. Let's do one more here. This question is a little different. It's 3 over 6 cubed. Okay, no brackets. Okay, if there's no brackets around the fraction, that tells me that the only thing I'm cubing here is the 6. Okay, so only cube 6, okay, in the bottom or in the denominator. So if the whole thing is not in brackets, then we don't cube everything. Okay, that 3 just stays exactly where it is on the top, and on the bottom I'm going to cube 6. Well, 6 times 6 times 6 is 216. Okay, and there's my answer. Okay. Again, for these questions, if you can simplify your answers down with fractions, you do want to do that. Okay, so in this case, I can actually reduce the number 3 and the number 216. They're both divisible by 3. So I could reduce this fraction to be 1 over, well, 216 divided by 3 is 72. So if I put my fraction in lowest terms, okay, which is a better answer, then that's my answer there. Okay. Over here, this fraction that we had before, you might try to reduce that one. So you might try dividing both the numbers on the top and the bottom by 3, but 64 divided by 3 does not give me an integer. It gives me a decimal, 21.333. Okay, you might try 2 as well, but 27 is not divisible by 2. Okay, that gives me a 13.5. You could try 4. You could go on for a while, but nothing's going to work. So this is already in lowest terms. But when you are dealing with fractions, we should try to get our answer into lowest terms, if possible. Okay. Some examples of cube roots, finally. Again, you can use your calculator. Hopefully, you will start to recognize some common cube roots, but certainly you can use your calculator for these. Okay, so let's do some examples. Let's say the cube root of 125. Okay, you might recognize that 125 is a perfect cube, and it comes from 25 multiplied by itself 3 times. So 25 cubed is actually what gives us 125. But again, you could use your calculator here. Cube root of 125, and the answer is 25. Okay, let's do, this is a great one. Cube root of 1. Okay, not a trick question. And it's really important that you don't think of a cube root as, this is not 1 divided by 3. Okay, really, really important here. Cube rooting is very different than dividing by a number. Okay, it's asking you to work backwards, okay, or to undo multiplication by thinking, what number, okay, multiplied by itself 3 times would give me that number inside the root symbol? Well, 1 multiplied by itself 3 times will still give me 1. In fact, 1 multiplied by itself 1,000,000 times will give me 1. Okay, so the answer here is simply 1. If you take any root of 1, the answer is going to come out to be 1 here. How about this one? The cube root of 8x cubed. Okay, again, think about what's inside the root symbol. Well, 8 is a perfect cube. Okay, if I cube rooted 8, I would get 2. Okay, because 2 times 2 times 2, 2 cubed gives me 8. Okay, and if I want to undo the cubing on x cubed, just think about that. How did you get x cubed? Well, x cubed comes from taking x and multiplying it by itself 3 times. So x cubed is equal to x times x times x. So if I want to cube root 8x cubed, it'll give me one of those factors, okay, back. So I get 2x as my answer. And again, if I wanted to check that, to get back here, okay, I could simply cube the whole thing. And it should give me it has to give me the term that I had inside the root symbol. And it would, because 2 cubed is 8, and x cubed is x cubed. Okay? finally, one last one here for us, just to check, make that our calculator is working for us. Let's take the cube root of 2,744. Okay, this one you might not recognize right away. So if you use your calculator for it, okay, put in the cube root button to your calculator, or you may have to put this number in first. Okay, and then your cube root button, and then the 3, and you should get a 14 as your answer. Okay, because 14 times 14 times 14 is 2,744. I've got one final note here on dealing with negative numbers, okay, which is on the bottom of the same page. Just a couple of quick rules when we're dealing with negative numbers in multiplications or in taking roots. When you square a negative number, the answer is always positive. Okay, really what I want you to get from this is that a negative, okay, times a negative is always going to give you a positive number when you're using multiplication. Okay. So for example, negative 5 squared is negative 5 times by itself, and that's going to give me positive 25. When you cube a negative number, that means you're going to use that negative number 3 times in a multiplication. You're always going to get a negative answer. Okay, because 2 of those negatives will cancel to give a positive, but you're still left with 1 negative. Okay, so let's say negative 5 cubed is going to give me negative 125. Okay, so you can extend this rule to any exponent. Okay, basically, if you have any negative number, okay, so let's say a negative number, raised to some exponent, I'll call it n. Okay, this is the rule. Okay, if n is even, so in other words, it's equal to 2, 4, 6, 8, 10, okay, the answer will be positive. Okay, because a negative multiplied by a negative, okay, any number of times, if it's an even number of times, I will always get a positive answer. Okay, if n is odd, so for example, if n is 3, 5, 7, if it's an odd number, the answer will always come out to be negative. Okay, that's just a really simple rule of thumb for you. Also remember, if there are no brackets around a number, okay, then you don't apply the exponent to that negative number. You leave the negative sign out front. Okay, right? So if it's negative 7 squared, okay, you leave that negative sign out front. You're only squaring the 7. Okay, if the question wants me to square negative 7, it has to have brackets around that negative 7. Okay, so in this case, it would be equal to negative 49. Okay, and another example here, if I have a negative sign out front, let's say I have brackets like this, okay, with another negative inside. Okay, again, just remember that what's in the brackets is what you're cubing. So we would have negative 5 times negative 5 times negative 5, which is equal to negative 125. But this negative sign right here still has to stay out front. Okay, so if you have a negative sign up front and you've got a negative number that you're cubing, your answer is going to come out to be positive, because a negative, what I have here is a negative times negative 125. So these two negatives again do make a positive, and we get our answer is 125. All right, so I'd like you at this point, I'm not going to ask you to do these textbook questions. I'd like you to do on your worksheet 4.1. Okay, you can go back to page 1 of your worksheet, and you can do any of the questions that ask you to cube a number. And you can do on page 2 all of the cube root questions. Okay, and check your answers. Thanks for joining me. Good luck. And there's one last lesson, a quick lesson on factor trees. Okay, so I'll see you for part 3.